Welcome back. So today we're going to be working on solving systems using the substitution method. So first we need to look at the system that we are given. It says negative 5x minus 4y equals negative 28 and negative x plus 2y equals negative 14. So the first thing we need to do right now is we need to check, do we have a variable that's already solved for? What do I mean by that? Well, I'm looking to find, is there a variable that is isolated that looks in the form of y equals or x equals? Hopefully, looking at these two equations, you will notice that none of the two equations are in this format, which means none of the variables are already solved for. So in that case, I'm going to have to manipulate one of the two equations to be in the form of y equals or x equals. So first I have to take a closer look at the two equations that I'm given. I'm going to have to decide which variable should I isolate and from which equation. I have four choices in this case. I can isolate x from the first equation, y from the first equation, x from the second equation, or y from the second equation. Hopefully you've remembered in class that I've always told you that the best variable to isolate is the one that has a coefficient of 1 or negative 1. Reason being is because usually when you have to divide when you're solving, the last step is to divide off the coefficient. And whenever you're dividing by a 1 or a negative 1, the digit doesn't change. The signs may change, but again, the digit won't change. So let me give you a quick example so you can kind of follow along with me. If I am given something like 3x plus 1 equals 9 versus versus negative x plus 1 equals 9. Notice these problems are almost identical except one has a coefficient of a 3 and the other coefficient is a negative 1. Let's see which one leads to a better answer. So first I'm going to go ahead and subtract a negative 1 from both sides, leaving me with 3x equals positive 8. The very last step right now is to go ahead and divide off the coefficient, which in this case is a 3. And notice, what do I have now? I have x equals 8/3. I have a fraction. Well, now let me take a look at the other problem where the coefficient was a negative 1. I'm going to go ahead and do the same step of getting rid of my constant, leaving me with negative 1x equals 8. The very last step, again, would be to divide off the coefficient. So x equals negative 8. So notice, it is a whole number. This would be ideal. Why? Because I personally would not want to plug in a fraction into the two equations that I have. I would rather work with whole numbers versus fractions. So notice the lesson to be learned from this particular problem is make sure that you always isolate a variable that has a coefficient of a negative 1 or a 1 because it will not leave you with a fraction. So I'm going to clean up the mess I just made and let's go ahead and check to see. In that case, which variable should I isolate? Hopefully your answer would be the x from the second equation. Why? Because my coefficient is a negative 1. And that very last step where I'm going to have to divide off my coefficient, it will not turn my equation into a fraction, which is going to be perfect. So now that I've decided which variable to isolate, I'm going to go ahead and do that, which means I'm going to circle my x term to determine what needs to stay. I'm going to go ahead and get rid of the positive 2y that's keeping the x from being isolated. So I'm going to subtract negative 2y from both. I'm going to subtract 2y from both sides, leaving me with negative x equals negative 2y minus 14. the very next step is to go ahead and get rid of the coefficients. If you're wondering, what is a coefficient? Please remember that there is an imaginary 1 right in front of that x. So how do I get rid of a negative 1? I need to go ahead and divide both sides by a negative 1. So what do I get after that? I'm going to be left with x equals a positive 2y plus 14. I'm not quite done yet. I need to go ahead and substitute in that value in from my x into the other equation. Please make sure that you do not plug in this value into the equation you just manipulated. You need to make sure you substitute it into the other equation. So I'm going to go ahead and do that. When I do, I'm going to make sure I include parentheses because they were very important. Now, let me just show you the steps. First thing you do is substitute. Second thing is you ask yourself, is there anything that you can distribute? So in this case, the answer is yes. You're going to have to distribute the negative 5 to the 2y. Then you're going to distribute the negative 5 to the 14. Please notice that the parentheses is serving a role. It's telling you how far that negative 5 must be distributed. So again, are parentheses important? Most definitely. Once I do that, I'm going to go ahead and simplify, leaving me with the negative 10y minus 70 equals negative 4. Now, after you've substituted and you distribute, you have to ask yourself, is there anything you can combine? The answer for this particular problem is yes, there is. You're going to go ahead and combine the negative 10y with the negative 4y, leaving you with negative 14y minus 70 equals negative 28. So first, you substituted. You asked yourself if you can distribute. You've asked yourself if you combine like terms. Now you ask yourself, is there a constant for you to get rid of? In this case, the answer is yes. I'm going to go ahead and add 70 to both sides. You're left with negative 14y equals 42. Now the very, very last step, again, is to go ahead and divide by your coefficient, which in this case is a negative 14. So I'm going to go and do that, and I'm left with y equals negative 3. So what do you do from here? Now that I have a value for my y, I still need to find the value for the x. How do I do that? Well, I'm going to go ahead and substitute in that value into one of the two equations that I originally have. Please notice that one equation is going to be a little bit easier than the other. Please use your common sense and assess both of the equations. That way, you're going to save yourself time and it won't be too difficult for you. So I'm going to go ahead and plug it into the second equation because the numbers are slightly smaller and I feel as though it might help me complete the problem a little bit more quicker than if I plugged it into the first one. So when I do, I'm going to go ahead and make sure I have parentheses. So let's do the recap again. First, you substitute. Second, you ask yourself, is there anything you can distribute? The correct answer for this problem is yes. You are distributing the positive 2 to the negative 3. You're only distributing once, but it's still considered distribution. Now that you distribute, you're going to ask yourself, is there anything that you can combine? In this particular problem, the answer is no, so you're just going to go on to the next step. Now you have to ask yourself, is there a constant to get rid of? And the answer is yes. You're going to go ahead and add 6 to both sides, leaving you with negative x equals negative 8. And now the very last step is you must get rid of your coefficient. So in this case, your coefficient is a negative 1, which means you're going to have to divide both sides by a negative 1, leaving you with x equals 8. Now you are now you are finished. Please understand that your solutions need to be written as x comma y. So I would write my answer as 8 comma negative 3. Please understand that on a quiz, on your homework, on a test, it is so important that you check your work. Why? It's a method of making sure that you have the correct answer. If you're going to take all this time to work on this problem, you might as well get credit for it, right? So please check your work. How will you do that? You're going to plug in 8 for all the x variables in the problem, and you're going to plug in -3 for all the y variables in the problem. Please make sure that when you plug it in to the first equation, you should get -28. When you plug it into the second equation, you should get -14. If it's true for both, you know you have the correct answer. But if there is a statement that leads you to a false statement, you know you did something wrong, which means you're going to have to backtrack and look at all your work to see where was the mistake made. So, please remember to check your work. That concludes the lesson for today. But before I leave you, I have a quick riddle for you for extra credit. So, the riddle is, what is a room that has no windows or no doors? If you know the answer, please come find me and tell me. Please make sure you don't share the riddle or the answer to anyone else. It's strictly between me and you. So again, thank you for watching my video. If you can, please subscribe. That way you can get updates of when the videos come out. Thank you for watching, and I will see you tomorrow.